Let's jump right in. We're going straight into the ultimate high-scoring strategy for the Cambridge IGCSE Computer Science 0478 exam. We're skipping the fluff and tackling exactly how to secure those top band marks. Because, let's be honest, if you've ever walked out of an exam hall feeling incredibly confident, like practically planning your victory parade, only to get your paper back and see a mysteriously low grade, well, this explainer is your exact blueprint for fixing that gap. We're going to completely deconstruct what examiners are actually looking for and honestly what they actively penalize.
I mean, take a look at this. We've all written a response exactly like this at some point. It makes the computer go faster, right? It's a classic mark trap. It definitely feels correct, and it's exactly the kind of everyday language you'd use when explaining a new laptop to a friend. But here's the catch. In the context of the 0478 syllabus, this is a really dangerous illusion of knowledge. So why does an answer that seems practically true score absolutely 0 marks? Let's dive into this and reveal exactly why ordinary revision totally fails and how vague wording literally destroys your grade boundaries. You see, in computer science exams, a massive amount of avoidable mark losses happen because candidates recognize a familiar word, panic, and then answer a completely different question from the one that was actually set. Abstract words like faster or better, they give the examiner absolutely nothing to mark. They just don't prove you understand the underlying digital problem.
Which brings us to Section 1, the top band framework. This is all about extracting the marks.
To pull those marks directly from the examiner, we have to immediately shift away from rote memorization and move towards a strategic, layered answering framework. Seriously, it's time to stop viewing the subject as a massive vocabulary list and start seeing it as a beautifully connected structure of systems. The absolute crucial point here is understanding this hard boundary, description versus explanation. If you only describe, just telling the examiner what a device or process is, your answer is safe, sure, but it's really shallow. You might pick up a single mark. But an explanation, that tells them exactly how it works and why it matters contextually. That's what scores the real marks. But wait, if you leap straight into explaining without naming the concept first, your response just sounds confused. The real magic happens when you combine both.
So instead of just dumping facts in a random order, you're going to use our 4-step method mark strategy to logically build an answer. Step 1, identify the demand. Like, what are they actually asking you to do? Step 2, classify the correct concept or process. Step 3, explain the sequence step by step. And please, do this without jumping backwards and forwards. Keep it linear. And finally, Step 4, the contextual check. This is where you literally pause and verify if your answer directly addresses the real-world scenario given in the prompt.
Okay, moving right along to Section 2, mastering clock speed. Time to solve some digital problems.
Let's actually apply this golden framework to a highly specific practical case study, clock speed and performance. We aren't going to look at this as just some isolated definition floating in a textbook. No way. We're treating it as a real digital problem that solves a specific issue for a user or a system. We're going to move through 3 distinct learning layers here, transforming a basic digital problem into a context-driven, examiner-friendly response. The first pass is securing the simple everyday explanation. The second pass rehearses the technical vocabulary. But here's the kicker. Students often falsely think they know a topic until they try to express it in that third layer, the exam-level explanation. This is where you have to take those technical words and shape them into a logical sequence under intense time pressure.
Now, in just a moment, I'll show you the exact examiner clue that completely changes a clock speed answer. But first, you really need the framework that makes that clue super obvious. The clue usually hides in the contrasts, and if you don't know the boundaries of the theoretical concepts, I promise you, that clue will fly right over your head.
And here is why. Mixing up these theoretical contrasts is the #1 reason candidates answer the wrong question. Think about it. Memory versus storage, data versus information, compiler versus interpreter. Your computer science reasoning becomes vastly stronger once these boundaries are clearly understood. The examiner's clue is always pointing to one side of these contrasts. If you miss the distinction, well, you end up describing a related idea that isn't actually the one being assessed, and that leaves the examiner absolutely no choice but to withhold the marks.
Let's get into Section 3, flawed versus perfect answers. Time for an answer teardown.
This is where we put all that theory into practice. We're looking at the exact wording that separates an average student from a top-tier candidate. Notice how the flawed answer on the left kind of just floats in total abstraction? It basically just repeats the prompt using everyday language. But look at the perfect top-band answer on the right. It uses scientific reasoning anchored in a specific school database context. It says, increases fetch, decode, execute cycles per second. Boom. It names the core mechanism. And then, improving the school's database query performance. It locks that mechanism directly into the required context. Guys, that is a beautiful, undeniable mark-winning sequence, right there.
You have to remember, examiners actively penalize these specific mistakes. So you must explicitly connect your step-by-step explanation back to the real-world scenario, whether that's a website or a secure network. If the exam question is set in a school, an office, an industrial automated system, or a retail environment, your answer absolutely must stay inside that environment. Stating an advantage with zero reasoning or identifying a device without justifying why it fits that specific scenario, yeah, those are the absolute easiest ways to throw away a grade boundary. Just don't do it.
All right, Section 4, Principal Examiner Warnings. Let's talk about error-aware revision.
Let's elevate our strategy here by listening directly to some insider secrets straight from the marker's perspective. Error-aware revision is infinitely more useful than simply memorizing correct facts. We need to know exactly what annoys the person holding the red pen, right? As this quote perfectly highlights, students so often fixate on a device name or a familiar symbol and entirely ignore the deeper process at play. You really cannot rely on memorized wording alone. You have to understand the deeper processor mechanisms and sequence them logically. But if you can accurately paraphrase the core mechanism in your own words, that knowledge becomes totally adaptable. It actually survives the stress and time pressure of the exam hall. So before you submit any response, run it through these 4 final checkpoint questions to guarantee you haven't left any easy marks on the table. 1. What is it? 2. How does it work? 3. Where is it used? And 4. Why is it better or worse than the alternative? If you can silently answer these 4 prompts in your head while reviewing your written response, you have crafted a comprehensive, top-band answer. It literally forces you to explain the mechanism first and state the consequence second.
We've built the foundational framework today, and we've looked at the exact phrases that separate an average grade from a perfect score. So the next time you sit down in that exam hall and stare at a blank dotted line, you have a choice to make. Are you going to panic and just write down the very first familiar word that pops into your head? Or are you going to take a breath and deploy a perfectly sequenced top-band explanation?